Okay, so we're going to talk about the square root property. Oops. And now I'm in a yellow pen. Hold on. There you go. Black pen. There you go. Square root property. Okay, so we've solved equations like 25 squared or x squared minus 25 equals 0. What's the difference of squares, right? X plus 5, x minus 5. We use that by factoring. But we can also doing it by using the square root property to solve this. So let's look at how to do that. So the key concept, I'm not going to go over the key concept actually. I don't like the way they do that. So we're just going to go over example 1. So this is on page 306. First one to find it, please tell me what page it's on. We're example 1, page 306. So you can't see the board, Brian?
No.
Did you accept my request for it? The sharing request?
Yeah.
Okay, I'm going to do it again then.
It's A306.
Alright, thank you. A306. Okay. So, can you see it now, Brian?
I can see the bell.
You can see you should be able to see me.
I can see you now, yeah.
Okay, or the wrong thing. Left thing. Alright, so square root property. So example 1 says solve x squared plus 10x plus 25 equals 49. What do you see about this problem? What do you notice? We're talking about square roots.
They're all like squares.
Well, yeah, 2 of them are. Well, 3 out of the 4 are squares. We have x squared, and we know 25 is a perfect square, and we know 49 is a perfect square. So how can we factor out x squared plus 10x plus 25? What do we know that ends up being?
X plus 5 and x plus 2 or something like that.
If 25 is a perfect square,
Or x plus 5.
right, so we have x plus 5, x plus 5. So we can write that as open parentheses. X plus 5 close squared. Because if you factor that out or you FOIL it, it's like Nathan said, x plus 5 times x plus 5, you end up with x squared plus 5x plus 5x or plus 10x plus 25. So, yeah, so you can write it as open parentheses, x plus 5 closed squared equals 49. And from one of the last sections, what do you notice about each side? What can you do to each side? We have x plus 5 squared equals 49. To simplify it, to get rid of that square. And still get integers as your answer. What happens if you take the square root of each side? Is that possible? So what happens if we take the square root of x plus 5 squared? What do we get?
X plus 5.
X plus 5. What happens if we take the square root of 49? 7. Because remember, what you do to one side, you have to do to the other. And looking at this problem, we go, aha, we can take the square root of each side. And what are we finding? What are we trying to find as our answers? The roots, right? So taking the square roots of 49 is 5. So we're just looking for these roots. But Do you remember the whole thing about the plus or minus? When you take the square root of that 49, it's a plus or minus because we're looking for the principal root. So it would be x plus 5 equals plus or minus 7. Because how many roots do we get with the quadratic formula? Or the quadratic equation? 2. So we always have to have the plus and the minus. So let's look at this. X plus 5 equals 7. And x plus 5 equals negative 7. So how many answers are we going to get? 2. So what are our two roots? What's x plus 5 equals 7? What's x equal? 2. And x plus 5 equals negative 7. We solve that and x becomes? Negative 12. So our solution set is open brace, negative 12 and 2. So that's solving by completing the square. But you have to have perfect squares to make that work. So if you notice this one, our C term is a perfect square and our last term is a perfect square. So this works when we have those conditions. Okay? So now let's look at the example on page 307. Very top of 307. So we're going to talk about irrational roots. So roots that are irrational numbers, they can be written as exact answers in radical form or as approximate answers in decimal form when we use a calculator. Yes, C term and the last term are the same thing. Okay, so let's go through this problem and I'll tell you what I'm talking about. So we can do it in radical form, that's when you have a square root in your answer, or in decimal form, it's approximate because, they can go on. The rational numbers never end, so it's always an approximate answer. So example 2 says x squared minus 6x plus 9 equals 32. Okay, so we're going to complete the square. This time we're not going to get integers, but we can still complete the square. So because looking at the left side, we have x squared minus 6x plus 9. And what do we notice about that one? That's similar to example 1. We know 32 is not a perfect square, but what happens with this x squared minus 6x plus 9 when we factor it? Can we make that into a square?
Yeah.
Okay, Anastasia, tell me how we do. Well, let's look at our middle term. We have x squared minus 6x.
Yeah.
So would it be x plus 3 or x minus 3?
X minus 3.
Right, x minus 3, x minus 3. So let's just go through the foiling and see how it works. So x minus 3 times x minus 3. So that's x squared minus 3x plus 9. It works. Okay, so the left side, when we factor it, becomes open parentheses, x minus 3 close squared equals 32. Okay, so we can take, we have open x minus 3 close squared. Equals 32. The original equation was x squared minus 6x plus 9 equals 32. And then we were able to factor that left side out and get x minus 3 squared equals 32. Okay, so we can take the square root of each side, and then we get rid of that x squared, which we need to do to be able to find the roots. So what happens when we take the square root of x minus 3 squared? What are we left with?
X minus 3.
Correct. Equals, and what we do to one side, we have to do to the other side. So then we take the square root of 32, so it's plus or minus square root of 32. So there's two ways to deal with this. We can either leave it in radical form, but we have to simplify it down as much as we possibly can. Or we can turn it into a calculator. So let's start by simplifying the radical. Is there anything we can pull out of this plus or minus square root of 32? Are there think about any factors of 32 that are perfect squares? What are some factors of 32? We have 1 times 32.
2 times 16.
2 times 16. And that's a pretty big square, isn't it?
Yeah.
So we can pull that out. So what if we pull out that 16 from the radical, what does it come out as when we take the square root of that part?
4.
4. Right. And we're left with, so now on the left we have x minus 3 equals plus or minus 4 radical 2. Because that 2 still is hanging out under the radical sign. Or to the right of your radical sign. It's still under the radical.
4 radical what?
2. 32 simplified is 4 radical 2. Okay, but we're not finished quite yet, because we still on the left have this x minus 3. So what happens to that negative 3? We want the x by itself. Where does it go?
Nowhere.
We move it to the right, right? So they end up with x equals 3 plus or minus 4 radical 2. Okay, and then we have to break this apart. We end up with x equals 3 plus 4 rad 2 and x equals 3 minus 4 rad 2. Guys, remember it's a plus or minus in front of our radical. And those are your answers if you leave it in radical form. But you can get out your calculator and punch in 3 plus 4 radical 2 and you'll get an answer. And then you put in 3 minus 4 radical 2 and you end up with approximate. So you get x is approximately 8.7 and x is approximately negative 2.7 as your answers. Okay. Everybody good so far?
Yes.
Okay. So now that's looking at problems where we have a perfect square on the left side. Notice both of them did. Now we can complete the square even if it's not always a perfect square. So basically, let's look at page 307. So this is called completing the square. That's what this topic is. Completing the square. Okay, so let's start out with something. I'm going to just go straight to the example because there are explanations that get very cumbersome in Braille. So let's go to page 308. This is going to be much easier this way. So let's do 308. Very, very top. And it says, find the value of c that makes x squared plus 12x plus c a perfect square. then write the trinomial as a perfect square. So we don't have a C term. What do we need to put in C to make it a perfect square? We have to ask ourselves, how do we make it a perfect square? We have x squared plus 12x plus C. So what should C be in order to be a perfect square? So let's look at the steps. So there's 3 steps. So step one. Find the half of your B term. So you do B divided by 2.
6.
It's 6, right. So that would be 6. Okay. And then step 2, square that, your result of step 1. So then you have 6 squared. 6 squared equals 36. Step 3, add the result of step 2 to x squared plus 12x. So step 3 is you add your result to your equation.
Wait. No, so you add 36 to the equation?
Yeah, actually, you just basically it's replacing C with 36. Okay, because let's see here. So now we have x squared plus 12x plus 36. So this equation we can then write as x plus 6 squared. So we can make the left side of our equation be able to take the square root of it. By completing the square, we can make the left side a perfect square, and we can easily find our roots. So let's go all the way down to example 4. This is on page 308 at the bottom. So first person, can you tell me what page it's on? It's example 4, solve an equation by completing the square.
So is that it?
For the steps?
Yeah.
Yeah, that's for the steps. But now let's do an actual problem.
There's on D.
On D as in dog?
Yep.
Okay. So now let's look at this, let's look at an equation. So we have, and this is the reason why you're going to do this, we have x squared and we have x squared plus 8x minus 20 equals 0. Okay, so if you remember the steps, okay, let's find our roots by completing this square. We know negative 20 is not a perfect square. So the first thing we want to do is actually move it to the right. So then you get x squared plus 8x equals 20. Now we have a blank C term on the left. We don't have a C term there. So then we go through our steps. We take our B term, divide it in half. So what's our B term divided in half? If we have x squared plus 8x.
4.
4. Okay, then we square that, and that gives us our C term.
16.
16, because now we have x squared plus 8x plus 16 equals, and remember what you do on the left, you have to do on the right, so then you get 20 plus 16. So, but look at this left side before we go any further. We now have created a perfect square, right? Because we can rewrite this in factoring the left side. How? When we factor it out, how can we write it? if it's a perfect square.
Would be like x open x plus 4 closed squared.
Exactly.
Yeah.
Yep, that's exactly it. Right. So now what do we have on the right, since we added 16 to each side?
36.
36. Okay, so now on the left we have x plus 4 squared. On the right we have 36. So what are our two roots? How do we find our two roots? What's our next step? Now that we have an equation, we can take the square root of each side. So the next step, we use the square root property, and we square root everything in the equation. So we have x plus 4 squared. And we want to get rid of all those kind of squares and everything. So
X plus 4 and x minus 4.
or so it's just x plus 4, right?
Yeah.
When you take the square root. And then what happens on the right, the 36? This is where our plus or minus goes.
Plus or minus 6.
Plus or minus 6. Okay, so now I have x plus 4 equals plus 6, x plus 4 equals negative 6.
Like what?
So x plus 4 equals positive 6, x plus 4 equals negative 6.
Oh,
Okay.
okay.
Plus or minus. So what are our two roots? So what is x plus 4 equals 6 end up being?
2.
2. And then what is x plus 4 equals negative 6?
Negative 10.
Yes, negative 10. So our two roots are, open brace, negative 10, comma 2, close brace. So just to recap really quickly, you have on, when you have a C term that's not a perfect square, you kick it over to the right, you figure out by your B term, having your B term, what you need to put as your C term to make it a perfect square trinomial. You factor it out and you get your x plus whatever squared equals the operation you do on the right, plus or minus what you moved over. And then you square root each side. And from there, you then set it equal x equals plus the answer and x equals negative the answer. All right, so that's all I wanted to do for, let's see here, 3. That's all I wanted to do today for going over examples. Now it is now 1:55, and I'm going to give you the rest of the period to work on this assignment. But then what I also want you to do tonight for homework is I want you guys to read examples 5 and 6. And then I want you to email me a summary of those. Not examples, just kind of what you got out of it. So that's for examples 5 and 6.
Are there problems?
Yeah, they're examples.
Okay.
Yeah, one's equation with a not equal to 1, and the other one is equation with complex solutions. We get to revisit our friends, the imaginary numbers. So what you're going to be doing for homework, though, is on page, it's going to be on page 310. Let's see here. You're going to be doing 14 through 30 even. 14 through 30 even. And number